When we consider factoring binomials, it's good news and bad news. The good news is binomials always factor by a formula. And so if you know the formula, the factorization should be relatively straightforward. The bad news is binomials factor by formula, so you need to know the formulas. There's a chance you could stumble on the correct factorization for a difference of perfect squares, but it's unlikely that you would stumble on the correct factorization for a sum or difference of perfect cubes. The nice thing is binomials are either a difference of perfect squares, a difference of perfect cubes, a sum of perfect cubes, or they are prime, and they fit directly into a formula. And so as long as you know the formula, you should be okay. If, for example, we wanted to factor 9x squared minus 36, what we need to do is we need to figure out whether or not this is one of the three factorable forms. If it's none of them, then it's prime. And so the question that we have to ask ourselves is, can we rewrite this thing as either a difference of perfect squares or a difference of perfect cubes or a sum of perfect cubes? And there are some hints within it. First of all, the degree of this polynomial is degree 2. And so it really can't be a difference of perfect cubes or a sum of perfect cubes because those are degree 3 polynomials. If we want to know whether or not this is a difference of perfect squares, what that involves really is for us to identify what A might be and what B might be. And so we want to figure out what is it that when we square it gives us 9x squared. And so in this case, if we were to square 3x, we would get 9x squared. If we were to square 6, we would get 36. And so we're capable of rewriting this polynomial as something squared minus something squared. That makes this a difference of perfect squares. When you do it this way, you also are taking the time to identify what A and B are in your formula. So in this case, A squared minus B squared is 3x squared minus 6 squared. And so everywhere that there's an A in the formula, I'm going to replace it with 3x. And everywhere that there's a B, I'm going to replace it with 6. And so 9x squared minus 36 factors into 3x minus 6 times 3x plus 6. And if I FOIL it back out and check it, it works. I can do the same thing if I want to factor something along the lines of 8x to the third minus 125. Or you know what, let's change that. We'll make it 8x to the third plus 125. So again, when you first look at it, what is the polynomial telling you? So in this case, the plus sign here means this can't possibly be a difference of perfect squares because differences indicate subtraction. It can't be a difference of perfect cubes. Again, that would be subtraction. So the question we want to ask ourselves is this a sum of perfect cubes? Is it possible for me to rewrite this as something cubed plus something cubed? And in fact, 2x to the third power is 8x to the third, using the rules of exponents. And 5 to the third power is 125. So again, this falls right into our formula. A in this case is going to be 2x, and B in this case is going to be 5. So I can start to plug everything into my formula using the formula for the sum of perfect cubes. So A plus B, that's 2x plus 5. A squared is 2x squared minus A times B plus B squared. Now this is very ugly, right? Does not look the way we want it to look. Put it all on the same line. we need to simplify the second polynomial. And so to simplify it, the first polynomial stays the same. 2x squared using the rules of exponents, that's 4 x squared. 2x times 5 is 10x, and 5 squared is 25. Now we have a polynomial that looks the way that we want it to look. Okay? Make sure you take the time to learn the formulas. You'll need them for the test.